Let's do another problem of transient analysis using of a circuit having all the three RLC. As you can see here R, L and C are all in parallel. So part 1, we will try to find out what is going to be the voltage that will be at this inductor and this capacitor. If you look at the question is the switch is opened at time t is equal to 0. So before that the switch was closed. So before that, when the switch was closed, what is going to happen is, since this is short, all the current will pass through this branch and fairly long amount of time has been taken here, and so we will have to apply the conditions here. So in part 2 we will have only the circuit, which is not only the circuit, we will have the circuit with all the components just like we are having in part 1. So let's do part 1. So in part 1, as we can draw here, it is a current source of 2 amperes, then the switch is closed, so I can say that the switch is closed, so it is a short circuit, followed by an resistor which is 0.5 ohm resistor, then an inductor which in steady state is basically also a short circuit, then we are having a capacitor which we know in steady state is open circuit, and that's what we are having in this particular equation. As you can see, we want to find out what is the current that is passing through here, so that we get I of 0 minus, as well as what is the value here, so that we get V of 0 minus plus minus. That is what we want to find out. Now since the circuit is short here itself, what we can see is that the whole current will pass through this. No current will pass through this connection, so I can say that I of 0 minus is equal to 0. And since no current is going to pass through this one, all current will pass through only this one, no current will pass through this one. So the voltage drop across this will also be equal to 0. So I can get V of 0 minus is equal to 0. So now we have found out that the value of I0 and V0, sorry, I of 0 minus and V0 0 minus is all 0. So there is no charged current or charged voltage across the capacitor. And it is understood also. Why? Because see, when you close this circuit here, what happens? All the current will directly go through this one. So the capacitor, neither the inductor will get charged. Now what will happen when this one opens up? When this one opens up, all of a sudden you are going to have the current passing through all the elements. Now here we have to draw the Laplace circuit. If you remember, we always draw the Laplace circuit. So we have to take the Laplace. Now remember, the switch is getting opened at t is equal to 0. So in effect, we can say that the 2 ampere current source is coming to play only at t is equal to 0. So I can write 2 u of t as the current that is passing through here at t is equal to 0. So based on that, if I try to take the Laplace of 2 u of t, we will get 2 by s. In class also I have said that generally if you are having a switch, the operation of which makes the source connected to the circuit, then the source will be basically multiplied with u of t, or in Laplace you will have to write whatever is the source value divided by s. Okay, now with that, now the circuit is open, so there is nothing here. Then we are having the parallel components. One is 0.5, 0.5 ohms. Another is inductor. Since there is no charge current, so the voltage is 0, so we are having only 0.5 H. And then we are having the capacitor. Sorry, I cannot write 0.5 H, I have to write in Laplace. So in Laplace this will come as 0.5 S. 0.5 S, and the capacitor, we all know that is 0.5, so I can write 1 divided by 0.5 S, which is equal to 2 by S. And then we try to take whatever is the voltage across it, and that will be our capital V of S. So now we know that it's very simple, because all we have to do is V of S will be the current through the parallel combination. So the current through the parallel combination will be voltage will be 2 by S current multiplied with the impedance. Impedance is 0.5 parallel with 0.5 S parallel with 2 by S, which is 2 by S, and then we have to take the inverse. So inverse of 0.5 is 1 by 0.5, which is 2, plus the inverse of 0.5 S is going to be 2 by S. Okay, the inverse of 0.5 S is going to be 2 by S, and the inverse of 2 by S is going to be S by 2, the whole inverse. So if I am going to calculate what is there inside the bracket, let me write 2 by S. So in the denominator I will get 2S, in the numerator I will get 4S plus 4 plus S square, the whole inverse, which I can write now V of S is equal to, if I take the inverse of that, then I will get S and S will get cancelled. I will get 2 multiplied with S, not multiplied with S, 2 divided by S square plus 4S plus 4. Now we have to do the partial fraction. For that we have to find out what is the root of this one, and we found out that the root is same, -2, so we can write 2 divided by S plus 2 the whole square. Let me look whether I have made any mistake. Yes, this should be 2 into 2, which one, this one comes as 4. Okay, since V of S is 4, V of t will be Laplace inverse of V of S, and we already know that, if you are having 1 by S plus A, its Laplace transform is e raised to power minus at u of t. If you have 1 by S plus A square, its Laplace transform is given by t e raised to power minus at u of t. We already know this by property, so I will straight away write here, therefore V of t is going to be Laplace transform 4 I will take outside, the remaining 1 divided by S plus 2 the whole square is t e raised to power minus 2t u of t, which I will write it as for t greater than 0, and that is going to be the answer for this one. Now let me take another case in which again we are having RLC, but we are having it in series. So in this circuit, as you can see that the capacitor and the inductor are not completely in parallel. They are having in resistance 1, so they are not completely in parallel as we had done in previous. This question also has all the 3 elements R, L and C in them. So let us solve them. So we will first do part 1. As we know, in part 1 we try to find out what are the initial conditions associated. So the question is saying the switch is opened at t is equal to 0. So that means the switch was closed first and it is opened at t is equal to 0. Steady state condition is achieved before t is equal to 0. That means while the switch was closed, it has achieved steady state condition. Now they are asking us to find out I of t. Okay, if the circuit was closed like this, the current was passing through the capacitor as well as inductor, so it is charging both of them. So we will have to find out what is going to be the associated voltage across the capacitor and the associated current passing through the inductor when both of them had been completely charged. That is because we have already said that they have achieved steady state condition. So let us draw the circuit when the switch was closed. So we are having 1 volt and then the switch was closed. So here the capacitor after charging up is acting like open circuit with plus minus polarity V of 0 minus, and we are having the inductor which is acting like a short circuit with a current of I0 minus. So this is part 1, 0 minus, and there is a resistance in which nothing has happened as such. It is just 1 ohm. Okay, now looking at this circuit, I can very clearly see that the 1 volt source is only seeing a 1 ohm resistor. Therefore the current that is passing through here, which is the same as I0 minus, is going to be 1 volt divided by 1 ohm. 1 volt divided by 1 ohm, which is going to be 1 ampere current. If that 1 ampere current is passing through this, then I will have plus minus 1 ampere into 1 ohm. So I will get the voltage across this as 1 into 1 as 1 volt. The same thing will, as you can see here, this is 1 volt. So the voltage across this should be equal to 1 volt. So I will write V of 0 minus is equal to 1 volt. So I have got the answers of initial condition. Now once I have got that, I will do part 2. In part 2 I have to draw the Laplace circuit. Always remember we have to draw the Laplace circuit. Laplace circuit means we will have to represent the inductor and capacitor in its Laplace form, also the current. So once this switch is open, this much part of the circuit is not going to be connected with the main remaining circuit. So avoiding that, I will draw a capacitor whose value is 1 divided by 1s, which is 1 by s, and there is a voltage source. Since the current was flowing in this direction, that means it is flowing in downward direction, so I will assume this as plus and minus with value of V naught minus, which is V naught minus by 1, sorry, not inverse, V naught minus by 1, by s. So V naught is 1, so this is also going to be 1 by s. And then we are going to have the inductor, where the inductor is going to be 0.5 s, followed by a voltage due to the current is passing like this, so this should be negative and positive. Okay, so this value of this one is L I naught. L is 0.5, I naught is 1. So let me write L I naught minus is going to be 0.5 into 1 is 0.5. And that, along with the resistance of 1 ohms, is the reason why we are having a current here, which is I of s. So KVL at mesh 1, there is only one mesh. At mesh 1, if current is passing like this, so we are having plus minus polarity, plus minus polarity. If I am going to take front of the component, then I will get 1 by s minus 1 by s into I of s, which is I of s by s, minus 0.5 s I of s plus 0.5 minus I of s is equal to 0. As you can see here, there are two values, so I will separate them out. I will get 1 by s from this one. I of s I will take common, then plus 0.5s into I of s, which I will take common, plus this I of s, which is plus 1 I of s, is equal to whatever is remaining is 1 by s plus 0.5, where if you can see from here, I will get 0.5 s square, because s into 0.5, plus s plus 1 the whole divided by s, the whole divided by s into I of s is equal to 0.5s plus 1 divided by s. So I will get I of s as I of s will be equal to, so if I take it the other side, this one will be 0.5s plus 1 divided by 0.5 s square plus s plus 1, and s gets cancelled. So now, but as you know that we have to keep the coefficient of the highest power as 1, so I will again write I of s. I will take 0.5 from the numerator, 0.5 from the denominator, and they will cancel off. So I will, once I take 0.5 outside, I will get s plus 2 divided by, I have taken 0.5 outside, so when I take 0.5 commonly outside, then you will get this one as 2, this becomes 2, then here I will get s square plus 2s plus 2, exactly. So this is the equation that I get, which if you remember, I have to do the partial fraction here. Actually partial fraction won't work. I will straight away write what is it going to look like. I can write this one as s plus 1 divided by s plus 1 square plus 1. If you remember, we had already taught in class how this can be written in this particular format. Okay, how to do the Laplace inverse transform. Okay, so if I'm going to do like that, then my I of s will become s plus 1 divided by s plus 1 square plus 1 divided by s plus 1 square plus 1. So now if I'm going to take the Laplace inverse, so let me write here, taking inverse Laplace transform, I will get I of t is equal to, this one is cos, but because of this plus 1, like if you remember, we have s plus a divided by s plus a the whole square plus omega square is always written as, the inverse of that will give e raised to power minus at cos omega t. So going by that same rule, I will get here e raised to power minus t cos omega is going to be 1 here, so cos t plus this is going to be sine, that means 1 divided by s plus a the whole square plus omega square is going to be e raised to power minus at sine omega t. So here I will write e raised to power, so let me take e raised to power as common, sine omega t, omega is 1 here, so it is sine t u of t, which I can write as for t greater than 0, and that is the solution.